Okay, so today we're doing identity and inverse matrices. We're going to actually spend today and tomorrow on them. For just so that we're all at the same spot, you're supposed to have done the work together on page 135. Hopefully everyone's through at least number 3 right now.
Yep.
Okay? Then we'll go into 4A, C, 5, and 6. So here's the first part. Number 1, find the product. Part A. What was the product here?
-5, 6, 4.
Okay, so it was, this actually ended up being your product.
Yep.
Right? And letter C, what was the product here?
3, 4, 1, -2, 0, 2.
Okay. So that should have been your product. Now we've talked about this matrix right here before, the diagonal ones going from left to right, everything else being zeros. We've talked about this being the same thing as the value of 1. So it's like multiplying your matrix by 1. It doesn't change the value. So when you have that diagonal set of 1s going from left to right and everything else is zeros, it doesn't change the value of what you're multiplying by. It gives you the same thing. And hopefully you'd see that when you multiply. -5 times 1 is -5. 6 times 0 is 0. So when you add those, you end up going -5 plus 0. And then -5 gives you times 0 is 0, and 6 times 1 is 6. So -5 times 0 is 0. So plus 6 that's 6. Yeah?
Does this apply to all matrices if you multiply them by the identity matrix, or just square matrices?
It would apply to all the matrices, if I understand the question. We're only going to be applying it to square matrices right now. Okay, so the point of doing this lesson is really what you're going to use in chapter 4. So out of everything else we've learned, I mean, you didn't know matrix multiplication, we reviewed the other stuff. Out of everything else we learned, this is going to help you to solve systems of 3 variable equations later on. This right here will directly relate to that. So I will reference this lesson here in the future. So if I'm predicting 1 chapter ahead, dude, I'm making a prediction there, Cole. All right? If I'm predicting 1 chapter ahead, I will actually say, hey, remember back when we did 3-6? When we talked about these matrices and this identity matrix? You remember that? Yeah, well, that's how we apply it right now. Okay, so we're going to apply that a little later. Describe any patterns you see. I think we've talked about the patterns. Let's check out number 3. So number 3, predict the product. What's the product going to be? Yes, sir.
2, 3, -2, 4, 1, 2,
Okay,
3,
so
0.
So this.
Yeah.
Okay, good. Remember, prediction, let's just base it upon what you've already seen. So hopefully you predict that. You can verify it with your graphing calculator, but this is your product because you're multiplying by essentially 1. So this is your identity matrix. That's your identity matrix. Okay, identity, when you multiply by 1, you get the same thing. You don't change the identity. All right, any questions there? Okay, switching gears, how many of you have done number 4? Okay, number 4, A and C, says find the product of, now I'm not dealing with B and D over here, but find the product of these 2 things. So if I'm multiplying this by this by this, okay, when I multiply letter A there, how many have done 4? 4A? Okay. Can I borrow someone's work there? All right. All the way back. All right. So it looks like 4A, when Tyler multiplied it, did you use your calculator, Tyler?
No.
You just did it in your head?
Yeah.
Wow, it didn't show any work or anything, but do it. When you multiplied it, he got an identity. Anyone else get an identity on 4A? Okay, 4B, or 4C, excuse me, also got an identity. Is that true? Okay. So when I multiply this matrix by that, there's an identity. This one by that one, they give you an identity. So multiplying these 2 things happen to give you that guy there. And multiplying, I'm going to put C's answer over here. Okay, but multiplying these two guys, they happen to give you an identity. These things right here, anytime you multiply a matrix by something else and you get an identity, you're multiplying it by its inverse. Now you guys have heard the term inverse before. Okay? Tell your neighbor where you've heard inverse before. So where have you heard inverse before? Hannah?
Inverse of parallel lines.
Inverse of parallel lines. I think you're thinking of like the inverse reciprocal.
Oh, okay.
Okay. Yeah?
Inverse proportions.
Inverse proportions. Anything else? Yeah?
You're right, if there's proof, and like you have like 5 initials.
Okay. Yeah, I know what you're talking about in geometry. Okay. How about doing this? Let's say I have 4x plus 3 equals 7. How do I solve? Yeah? Subtract 3. Did anyone know what that's called? It's called the inverse operation. Okay, this is the inverse operation.
That makes sense.
So by doing that, we do inverse operations. Okay, 1x equals, okay, 1x equals 1 there. Okay, so the inverse, when you multiply something by its inverse, you get 1. That's what's happening here. Just like in this problem here, let's change it up. Let's just say I have 3x equals 9. When I multiply 3 by its inverse, the inverse of 3 is
1/3.
1/3. I multiply by its inverse, you get 1. Everyone with me there? Now you guys have learned to divide there, but that's what's happening. When you multiply by its inverse is 1. Now you may go, well, why do I care? It's a valid question. The point of having this is next chapter, what you're going to do is you're going to be given problems like this.
That's awesome.
Okay, you're going to be given systems like that. You're going to write a coefficient matrix, a variable matrix, and a solution matrix. You're going to do reduced row echelon form, and the goal for you is to get down to this matrix right here. Because what this matrix says, it says 1x plus 0y plus 0z, and 0x plus 1y plus 0z, and 0x plus 0y plus 1z, in terms of how you're going to use these. You like this matrix. It'll help you solve this very, very quickly. But you have to know how to work these, and that's what we're learning today. Okay? All right. So right now, I want you guys to, well, any questions before we move on to that? All right. You don't actually have to write these definitions down. If you have, you may want to actually just do a quick picture of what an identity is. Explain to yourself maybe what an inverse is, maybe using your notes. I'm pretty sure everyone knows what a square matrix is, but maybe if you don't, maybe you should write it down. If not, you should tell your neighbor. Hey, really quick, what's a square matrix? Yeah?
It's when a matrix has the same amount of dimensions, like where it's like 2 by 2, 3 by 3, 4 by 4.
Good. Okay, square matrix. So we're going to be dealing with square matrices. All right? I want you to take a look at page 136 of your text. Or I guess you could look up here if you want. Page 136 talks about inverses. The goal of today is for us to be able to find inverses. Tomorrow, we're going to deal with using those inverses to solve matrix equations. But today, it's just to find inverses. All right? So that you're clear on what we're going to be doing tomorrow. Tomorrow, you're going to be given a problem, say like, well, say like this, times x equals that, and your job is going to be to solve it. Now earlier in the chapter, we were able, when there's an addition sign, it was easy. You just subtracted a matrix over. Here, you would have to divide by this matrix, right? If you're using math term, what you've done in the past, you do the inverse operation. Well, we don't divide by matrices. We multiply by their inverse. So the inverse is going to be whatever you can multiply this matrix by to get the matrix 1, 0, 0, 1. Okay, that's what we're going to try to get. So when you multiply a matrix by its inverse, you get the identity. So if you're trying to figure out exactly how all those things go together, think of it this way. If you have your original matrix, that's my original matrix. If I multiply it times the inverse matrix, it equals the identity matrix. And we need the identity matrix to be able to solve. So that's how all these things go together. Okay, that's really kind of simplifying it. But so our goal today is going to be to find the inverse matrix. Tomorrow we'll put it into an equation and we'll solve that equation. Okay? So, page 136 talks about this. Not all square matrices have inverses. So what would be really annoying is if you try to calculate an inverse and you can't actually do it, and you go through spend 10 minutes on a problem and you're like, dude, there wasn't even an inverse for it. Okay, so what you need to do is first test to see if there's an inverse. Austin, how's the Secret Service doing? They helping you out there? Nothing. Thanks, man. You know why we have silly rules? Like rules that students go, that's stupid. Why do we have that stupid rule? That's a dumb rule. How many have heard that before? Yeah, dumb rules. Why do we have dumb rules? Don't say because of dumb people. That's not it. Yes? Yes? No. Yes? Why do we have dumb rules? Yes?
Because teachers like to play Jedi mind tricks.
No, that's not it. Yes?
Because it's silly.
No. Yes?
Because there are those few people that actually don't follow the rules.
Yeah. There are those few people that will not, on their own, follow common sense rules. Do you understand? Yeah. Okay. All right. Make sure you're following the common sense rules. Inverse of a 2 by 2 matrix. Here's my 2 by 2. Suppose we have this. Just suppose we have this matrix. If AD minus BC does not equal 0, then A has an inverse. So your test, anytime you have a square matrix. Now, the question that will come up from most of you today is like, what if it's not 2 by 2? What if it's 3 by 3? What if it's 4 by 4? What if it's 5 by 5? Well, I will tell you today, you will be dealing with 2 by 2s only, unless you're using a calculator. In fact, this chapter, you'll be dealing with 2 by 2s only, unless you're using a calculator. Okay, there is a way to find the inverse of a 3 by 3. You won't learn that today. If you want, it's on my website. I could go through it tomorrow with you if you really want to see it. And 4 by 4 and 5 by 5, but it becomes extremely complex. That's when you love your calculator. Yeah?
Will we have to know how to do them?
You won't have to know how to do it for this year.
Okay.
Okay? So if they expect it in another year, they'll teach you how to do it.
Okay.
Okay? Most classes will now have you use a calculator for it. But you can research it. Like, I like that stuff. I go through and I figure out all these patterns. It's kind of fun for me, but maybe not so much for you. All right. So a 2 by 2, an inverse. If A times D, so that times that, minus B times C, that times that, is not equal to 0, then it has an inverse. So if it is equal to 0, then can you find the inverse?
No.
No, you can't. So the first thing you should always do is test that out. That is number 1. Do this test. First thing, test it. If you don't test it and you find out it doesn't have an inverse, you're going to be annoyed. Or you're going to come in and go, it doesn't work, McCoy. It doesn't work. Well, that's because it doesn't have an inverse, man. Did you do the test? No, I didn't do the test. Okay, try the test. It's really easy. In other words, the way I like to think of it If I'm just focusing on that top part, in other words, if I look at A and C, if I make this into a fraction right here, and make that into a fraction, just kind of like make a little line there, AC better not equal BD. Because if AC equals B over D, then, notice cross multiplying, AD equals CB. You guys remember doing that for direct variations?
Yeah.
Okay? If A over C equals B over D, then it's going to equal 0. So this, as long as these two fractions, if you make fractions here, are not equal, then you're good. Okay? If A over C equals B over D, then it has then there is not an inverse. It does not have an inverse. That is your quick check. So if I like throw up a bunch of problems here off your assignment, I look at this number 1. Does that have an inverse? No, because 1 over 1 equals 1 over 1. Does this one have an inverse? Yes. Does this one? Number 3, 4 over 8, negative 6 over negative 12.
It does not.
Nope, they both make 1/2, right? No inverse. Inverse?
Yes.
Yes. Inverse?
Yes.
Inverse? 10 over negative 5 is negative 2, and negative 4 over 2 is negative 2. The first thing to do is find out if it has an inverse. If it doesn't have an inverse, you're done. Some of you are like, hip, hip, hooray, dude, I don't even have to. No inverse. Woohoo, I'm done.
Okay.
Okay? All right. Once you go, okay, it has an inverse, and you're pumped up because you get to do more math, then you move on to this. If A times D minus B, C, so if it has an inverse, then the inverse of A, that's how you read that. That says the inverse of A. So make sure you know how to speak math. Anytime you see a negative 1 up in the power, that means the inverse of. The inverse of that is equal to this big mess. Give me a second here. Let's let people get that copied down.
Yeah.
Okay, the inverse of A is equal to, and I'll rewrite it over here, 1 over AD minus BC. AD minus BC is called your determinant, not a big time thing that we'll talk about. Times the matrix D, negative B, negative C, A. That is how you find the inverse of a 2 by 2. You figure out, you take your original matrix, you figure out what 1 over that is, you flip all those pieces around, you move them around, I call that my messed up matrix, and you do scalar multiplication. That will give you your inverse. Okay? Jaden, what's your question?
So like on the graphing calculators, is that what the x to the power of -1 button is for?
Yeah, that gives you your inverse.
Oh.
Yep. So for example, if I had this matrix, -1, 0, 8, -2. First thing, I just compare the fractions. I know it has an inverse. So now I have to go A times D, which is -1 times -2, minus B times C, or 0. So that gives me 2. That piece I put out here, 1 over whatever I get there. So 1/2 times, I move these things around. Those two switch spots. These become the opposites. So 1/2 of -1 is, or -2 is that. So on, this is my inverse. Now that's easy to say. I want you guys to try some. Okay. First one. I'll take a look at, these are off your assignment today. So you can do these in your notes, but they're off your assignment. I want you to do 1, 2, and 3 right now with your neighbor. Number 1. Without a calculator, find the inverse of each matrix if it exists. If it does not, write no inverse. Now remember, on your test this Friday, you won't be able to use your graphing calculator on a portion of it. There's actually 2 parts, one with graphing and one without. Okay? So on number 1 here, does it have an inverse? No. If I just compare the fractions real quick, 1 over 1 equals 1 over 1, that gives you no inverse. If you wanted to do, this is A, B, C, D. A times D is 1. C times B is 1. 1 minus 1 equals 0. No inverse here because it equals 0. Okay? Here, if I go that over that, and that over that. Does it have an inverse?
Yeah.
Yeah. So A, B, C, D. I go 1 times 1, 0 times 0. That equals 1. Okay.
That means it stays the same.
What's that?
That means it stays the same.
Yeah, so, well, yeah, this is going to be, you're multiplying by an identity here, right? But let's check this out. Remember, to find the inverse, we go 1 over AD minus BC. We know that AD minus BC is 1. So we put that on the bottom. So that is equal to 1 over 1, which you look at and you go, well, that's just 1. Okay, but you're multiplying that by, we have 1 over 1 times the messed up matrix, right? So the formula is 1 over AD minus BC that we use times our jumbled up matrix. A moves down to here, B moves up to here, or excuse me, D moves up to here. Okay, so AD, and then B becomes opposite, and C becomes opposite. All right? So, and if I'm doing that here, A moves, D moves, but they're the same number, so it doesn't matter. And B and C, their opposites are just 0. So really what happens, you get the same thing. And hopefully, for those of you that are really getting this, remember what I wrote earlier. Okay, if you multiply an inverse, the whole point of the inverse matrix is to take the original matrix and multiply by the inverse to get the identity. The only way you can multiply this identity to get an identity is to multiply by an identity. The inverse of an identity is the identity. Okay. AD minus BC in number 1 was 0. If I put 0 right here, 1 over 0, what do I get?
Undefined.
Undefined. That's why AD minus BC can't be 0. Otherwise, you get an undefined here. All right. Number 3. Can we do it?
Nope.
No. 4 times negative 12 is negative 48. That's negative 48. Subtract the 2, you get 0. No inverse. Number 4, can we do it? Okay, any questions up to there before we start 4? Dylan?
Wait, could you go up to number 3 again? I wanted to see something. Oh, never mind.
Okay, everyone try number 4 with your groupie. Find the inverse. All right, the formula for the inverse. There it is. 1 over AD minus BC times the matrix D, negative B, negative C, A. So AD minus BC, so when we do that first, we go negative 7 times 1, or negative 7, and negative 7 times 2, or negative 14. Negative 7 minus negative 14 is? 7. So AD minus BC, this portion right here is 7. So we now have 1 over 7 times the jumbled up, messed up matrix. And when we jumble it up, A and D switch spots. So D is 1, it goes up there. A is negative 7, it's now down here. B and C flip signs. So that was positive, it's now negative.
Oh.
Okay, that was negative, it's now positive. The way you find your inverse is using scalar multiplication, hopefully without a calculator. Now, common mistakes I see, students forget to put the 1 on top here. They just leave it as 7. Anyone do that?
No.
Okay. Other mistakes I see is forgetting the signs, flipping the signs. Anyone forget that?
No.
Okay. Anyone mess up moving things around in here? Okay. 1/7 of 1 is? 1/7. Don't be afraid of fractions. 1/7 of negative 2, or 1 times negative 2 divided by 7.
Negative 2 over 7.
Negative 2 over 7. 1 times 7 divided by 7. 1. And negative 1. Oops, negative 1. We'll make that a 1. We'll make that a 1. Now we'll make all of our 1s look like that. There we go. All right. There we've got it. That is my inverse matrix. If I were to multiply this by that, tell your neighbor what answer you would get.
1, 0, Get your identity.
Okay, what would I get?
Identity.
The identity. This matrix, the inverse, times the original will give me the identity. 1, 0, 0, 1. That's what we're learning here. Okay, any questions? All right. That's pretty funny. I get it. Okay, I want you to try number 13 on your calculator.
I don't know.
You need to plug that into your calculator.
Your calculator.
Okay. So, for those of you who have forgotten how to put these in, extremely quick review. First, pay attention, please. Second matrix. I have things in my matrices. I'm going to go over to edit. I'll just overwrite them. So I need a 2 by 2. I'm going to put in my 1, 1, 2, and 3. I'm going to hit quit. I now select matrix again, but I'm selecting A. I hit enter. And I want the inverse key. Now the inverse key is this guy right here. Okay? It's the matrix key, just without hitting second. So if you just hit that x to the negative first, it gives you that, and we hit enter. That's your inverse matrix. Okay? In fact, if you were to take this inverse, if I take the inverse and I multiply it by, so if I just hit times, that gives me my answer. And I should be able to now select matrix A. So if I go to matrix, unbelievable. All right, second matrix, select A. What should it equal?
1, 0, 1.
The identity.
1, 0, 0, 1.
Good. Should equal the identity. That's how you check.
Or you can just do a root
Okay.
1, root negative 1, which is just the inverse.
It's
More
amazing.
work.
Okay.
I can.
So the solution here, 3, negative 1, negative 2, 1. That is the inverse using our calculator. Now there are other things if you really want to know how to find the determinant. The determinant of matrix A is equal to 1. Everyone know what the determinant is? The determinant is your AB, or excuse me, AD minus BC. That's your determinant. So if I really wanted to calculate the determinant using my calculator, all it did was say 1 times 3 is 3 minus 2 times 1, which is 2, and it gave me my determinant of 1. You could calculate that if you really wanted to. That was under math, or second matrix, go to math, and it's the first option. Okay? All right, your assignment today.